You just have to focus, and
That's true.
within these 3 months, you should be able to finish everything.
That's very good. Okay, so let's just wait a couple more minutes. Still 2 minutes to wait at my time anyway. So we'll just give like 5 minutes extra of waiting and then we'll get started. Okay.
Okay.
Okay. In the meantime, I also want to try and do some microphone testing. So let me put on my camera. Okay, I need to switch the camera over. All right. Can you see me? Also, I'm going to switch over my mic. So please let me know if you can hear me clearly.
Yeah, we can hear
So
you.
I have switched the mic now. Can you hear me? Can you still hear me?
Yeah, we can hear you, sir. Very well, sir.
Okay, 1 second. Microphone. Yeah, okay. Can you guys hear me? Hello?
Yes, yes, we can hear you.
Yeah, but it's still
It's like we actually go where, and it doesn't matter which one I follow through, they're all gonna take me to page 2. Simple as that. I would recommend to just kind of playing with mouse overs and those styles. So let's say maybe you want to, I don't know, underline that thing. There are so many different options in actually to actually make it specific and interactive, and it's so easy to do as well. A couple of steps away, I can maybe.
Okay, so let me share my screen. Good. By the way, so I'm going to share this link.
Stay tuned, give it a like, share with your friends. If you have better ways to do so, leave a comment below.
So I'm going to share it with want to be to a comfortable level familiar with Git
I have a limited amount of tabs like this. What I could do is create a dynamic panel out of the tabs itself, out of the trigger.
That's the web one. So if you just click on that, that should take you to the web one.
Sort of trigger or active state across. Or even another way is just to make dynamic panel out of the trigger and just move the position, which is more advanced, which I can cover in another video. But let's keep it simple for now. And as you can see, now
Yeah. Okay, are we all good? Yeah.
Yes.
All right, cool. Let's get started then. So today we're going to be doing quite a few stuff going from where we have started. But most importantly is that we're going to be moving fairly quickly in the sense that we're going to complete all the AWS stuff we've been talking about. So we'll talk about an architecture, this architecture right here. Even though last week we focused on just one availability zone, but you understand that it's basically the same thing. So this diagram has everything completed. So everything on zone A, for example, is on zone B as well. And there are a few more arrows, but I'm sure it won't be difficult for you to comprehend. But then again, we'll go through everything one step at a time. So if you have any confusion, doubt, or whatnot, just let me know, okay? And then I'll explain it. Some of the things we have talked about, ALB, listeners, target group, all that stuff, but you may not have seen them in action, especially for those who haven't actually completed Project 15. For those who have completed Project 15, this will be fairly straightforward for you. And what I want to achieve is today and tomorrow complete the whole of architecture. Next weekend, we complete Terraform side of things, so that the week after, I think we're going to have a break in between to give you time to start focusing on Kubernetes, because after that, it's going to be Kubernetes and we'll spend a lot of time on Kubernetes. There's so much to do there. So this week, complete AWS. I don't know if it's next weekend, the Terraform, and then we go for a break, so that within that break, there are some videos you just have to complete. So you're completing all those videos will prepare us for coming back again to carry on with the Kubernetes side of things. So that in good time, you guys will be literally ready to go out there and start exploring. Okay. So now let me just walk you through this repo. So there's a file in this Masterclass repository, week 1 and 2. So every new week, just make sure you focus on Masterclass C, basically, because if you go to the main branch, you see a lot of, week 1, 2, 3, and all that, and you probably won't understand. And that was for previous batch. If you want to go through, fine, you can just explore, but this is your own branch. It's going to remain there, and we'll just carry on creating new folders, and then you can just flow along as we go. So week 1 and 2, you see a file here. So there's an MD file here. So in that file, we're going to go through what we will be implementing, okay? So that we can just take it one at a time, and you have like a process you're following to build the whole architecture that we've designed. And then there's this draw.io file. So basically, if you go to draw.io or diagrams.net, they've actually rebranded. It used to be draw.io, but now it's diagrams.net. But if you go to file and you import from device, you can just navigate to where that file is on the file system. Okay, so you can just select it, open it, and that should load up this diagram so that you can get to see it and just go through stuff yourself. Okay. And by the way, we're going to be using a domain, a real domain, to test what we're trying to do, because don't forget, this infrastructure is to enable us to deploy multiple websites, multiple applications into the same infrastructure, so that no matter what URL you go to, whether you go to masterclass.whatever.diary.io or whatever URL, as far as you have it configured in this infrastructure, your customer should be able to access whichever one it is. So having DNS resolve and going through HTTPS and all that, it should go down all the way down to your application and get data out from the database. So we're going to build everything. So what I'm going to do, I'm just going to put this on one of my screen on the left, so I can also have something to go through. Okay. And then, of course, obviously, I believe you guys also have a copy of it as well, so that we can all start going through it. Now, if you don't have this this PDF, let me share with you, just in case you just need that for information purposes. Okay, where is it? Where's my chat? Okay, found it. Okay, I'll send it to you on Slack as well. And what I'll also do is, after today's session, I'm going to add it to this repo and commit it and push it up so that you can always have access. So you just don't have one long, so you can have this short one, and with that short one, it will resolve to the long Figma link. Okay, perfect. So I believe you all have AWS account, and we're not new to what AWS is and what we do with it, or what we're going to be doing with it. It's just a platform that allows us to build infrastructure rather than have our own physical data centers. We could just go in the cloud. Going in the cloud basically means going to AWS website. That is our cloud. So it's not like there's something sitting up there in the cloud up there. Okay. So this is just a solution that a company has come up with. They have the physical data centers, and your gateway to access those physical data centers is by coming to their website and understanding the resources that you can create in there. You can begin to create your own infrastructure, build out your own infrastructure, have your own network in their network. But of course, you have to take care of things like security, high availability, disaster recovery, performance. They do their bit, making these services available to you. They do their bit as well to some extent when it comes to, especially when you're making use of some of their managed services. So they take care of some things for you from high availability, performance, and all that, but not all. Okay, not all, in the sense that you still have to take care of certain things. Okay, so those things that you have to take care of is what we will be looking after. And in this PDF right here, we have actually discussed this on our first class, where we talked about the business requirements, and we then talked about things we have to think about. Thinking about the network, thinking about the performance, how we're going to implement availability, security, all those kind of things. You can go through all that. So let's start with the very first thing in our implementation guide. is to create the VPC. And as we go through the implementation guide, we'll also be looking at the diagram, because from this diagram, you can see the very first thing we want to do is to create our private network. You know, if I remove all these arrows and everything there, what's going to be left is this big rectangle, okay? And that's our private network. So in AWS, there's going to be a big network of the entire AWS network, but we just have to carve our own. So the way to do that is to create a VPC, which is called the Virtual Private Cloud. And you see this search box right here. That's how you can quickly navigate to things in AWS. So if I wanted to go to the VPC section, I could just click, type in VPC here. And as you can see, it has its the link here you can click, and it says the isolated cloud resources. So that means you can create all your resources into this isolated area, and clicking on it will bring you to this page. So everything that has to do with networking is what you will find here. You can see here VPCs, subnets, root tables, internet gateways, security groups, ACLs, private gateways, you know, elastic IP. So everything that basically touches on networking, you will find it here, okay? Even though it says here running instances as well, so it shows that they're still putting in some compute related stuff, but most importantly, even on the left, you can see here, it's all about this networking. So you can minimize all these things. Okay, you can minimize them to see a lot more. So if you then open them up, you can see some of the things you can do with this category. So I really like this because it gets you to think about how they have nicely organized things. So if I go into DNS firewall, for example, you can see that you can do something that relates to DNS firewall related stuff. And then network firewall as well is there, VPN. So these are advanced stuff when you start thinking about doing configuration with on-prem infrastructure. So it's possible that your companies still have private data centers. So it is not all the time that companies put all their resources in the cloud, because you have to think about it. The moment you put things in the cloud, which is essentially another company's infrastructure, you don't really 100% control the data that you get to store in there. That means Amazon has access to your data. It gets stored on their server. So some businesses have problems with that. Some businesses frown at that, and they then come up with some kind of architectures that uses the cloud for compute. So you can put in resources in there, some applications that are stateless and doesn't really keep any data, and then still keep your private data center so that if you need to store data, that is where your data comes in. So if you think about it from this architecture, this layer of database, for example, may be taken out of this architecture and it goes into the private data center of your organization, so that when the application runs, you can scale instances, you can do all those kind of things. But when it comes to storing data, then it goes into the private data center. So to do those kind of things, you now have to start thinking about VPN, site-to-site VPN, and all those advanced things. Now that is beyond the scope of what we will be doing, because we're taking baby steps. Beyond Project 30, we have architectures that simulate things like that. And some of you may have already started working at the time, but you can still always come back and implement those kind of projects. Okay, so back to the console. And then as we're looking at the console, we're looking at the diagram, we're looking at our nodes. So we know on our nodes, the first thing we want to do is to create a VPC. So I can click on VPC here and then hit this button here that says create VPC. And don't forget that everything that we're going to be doing, we're basically simulating manual approach initially. Ultimately, all you're going to be seeing here will be done in code. And that's where the whole power of automation comes in. As a DevOps engineer, you won't be expected to be coming into the console to be clicking things. But the reason we're going through this is just for you to conceptually understand, first of all, how things work, so that it makes more sense to you when you start to do things automatically, okay? Now, when you're creating your VPC, it's possible for you to do a VPC and create your subnets alongside. The wizard allows you to do that. But for the sake of learning, we're not going to do that. If we were to do that, we would have selected that option. Okay, and you can see there's a preview here that nicely shows you how your subnets are going to be separated. The route table that guides you in terms of how traffic flows. But let's go with the VPC only so that we can name our VPC. So let's name it Masterclass C. So I'll just say MCC. So that's what MCC stands for. So we'll be using that going forward. And then the CIDR address. Remember last week we talked about this CIDR calculator thing, and we went here. So if you look at what it's suggesting to us here, 10.0.0.0/24, if you come here and calculate it, it gives you an idea how many hosts you'll be able to create out of this network. So what we will do is we'll do 10.0.0.0/16 so that we can have room for a lot more. So if I change this to 16, that will give us about 65,000 IP addresses. Okay. So you can leave every other thing as default. All right. And then just hit on the create button. So that's going to create our VPC for us. And that basically means that we now have a private network that we can now begin to put our resources into. Okay. All right. So if I go back to your VPCs, you can see this is our VPC right here. We had a different VPC. And if you notice, this VPC dev also has the same CIDR address. So there's not going to be any overlap because this is a separate network on its own. This is a separate network on its own. Okay, so I can just begin to deploy things into my MCC network. So whatever I deploy in VPC dev is not going to be the same as MCC. They're going to be separate infrastructure entirely. Okay. So on our note, actually, let me have a copy here as well, so that just in case I need to make reference.
Oh, Dario, please, sorry. Can I ask a question, please? Sorry.
Yeah.
Yeah. So does that mean that the CDR IPs don't have to be unique globally? They don't have to be unique globally.
No, because they are separate networks.
Networks, okay.
Yes. So they don't. So this is unique in its own right, basically. So they can have the same CIDR. It doesn't matter. They are completely separated, and you can have multiple VPCs like that. But I mean, it only makes sense for you to have separate CIDRs if you're going to be having multiple networks. The reason for that will be because there can be situations where you want servers to connect to each other across the VPCs. And you can imagine if a server has 10.0.0.1 in this VPC, and then the server that it wants to connect to has the same CIDR address, then that can be a bit of a problem. So that's why it won't say you shouldn't create it, but from a design perspective, if you know that there's going to be like a VPC pairing between these two VPCs, then it only makes sense for you to ensure that the CIDRs don't overlap. Okay.
All right, thank you.
All right, so the next thing is to create subnets, and then after that, we'll create the internet gateway. So from
sorry, Dar, I want to confirm something. I guess the IP addresses you're using for your VPC, I guess they are private IP, right? Not public IP.
They are. Yes,
so
they are private IP.
So you can have the same IP in different networks, and it won't matter.
No. Yes. So because they're private IPs, no one can even reach to them over the network. And if you remember when we were designing this thing last week, that was one of the first things we said, that when you create your subnets, they are private by default because even the VPC itself is private. So when you start dividing the networks, they are all private until you start doing specific things with a subnet that would then make it become public. So specific things like creating an internet gateway, for example, automatically and now makes it public because you can then access it through and then you create routes that route through the internet gateway. Then it becomes a public subnet. Okay, so that's what we're going to do now. So let's go into the subnets section, and then let's begin to create subnets. So obviously, we now want to divide our subnets within a VPC. So what you would have to do is to select the VPC that you want to create that subnet. So now I've selected the VPC, and as you can see, it says subnet 1 of 1, so I can keep adding to it. So how many subnets do we need? We need 1, 2, 3, 4. Okay,
we need about 6 if you are considering both AZs.
Yes, so in one AZ it's going to be 4, and then in the other is going to be another 4. So that means we're going to have like 8 altogether. So what we will do is let's give it a name. So we'll say, we can say MCC. So let's begin to give it a name. So first of all, this one is the public one, right? So let's give it MCC public A. Okay, let's use 1 because we're going to have like one public here, another public there, yeah? So which availability zone is this going to be? So we can select A, and because we're having 2 AZs, even though it's possible for us to have 3 because Amazon has given us 3 different availability zones. So A, B, and C. But in our case, we only have 2. Obviously, if our company has more money to spend, we can have the 3rd one. But again, you have to bear in mind that that's going to be costing us more. So for the sake of our learning, we're just going to stick to the 2. So we're now dividing the network. So we can now have 10.0.0. We can say 1/4/24. Okay, let's see if this is going to work. Let's calculate how many IPs this is going to give us. So this will give us 256. Okay, and then take note of this tag section. So tagging is very important because that's how your resources can now have ways in which you can filter, especially when you have a lot of resources and you want to quickly filter which one is which, what's what. So it's just a key value pairs that you can create. So as you can see, the key here is name, and then the value is the name that we've given it here. So this is how you're going to see it in the console once it's been created, that you can see that, oh, this is the name of this VPC, this subnet rather. I mean, you can create multiple tags. For example, if let's say we can say department, and then, you know, if the infrastructure is going to be used by the finance department, you know, all the resources can have something like this. So that if another department is working on an application and you're the DevOps guy, you know, supporting them, you can use key value pairs like this to separate. And then in some cases, some organizations, they have billing ID. So for example, they can give you a billing ID. And so if the billing ID is, let's say 1, 2, 3, 4, 5, 6, whatever, that means when they are spending within the organization, they can easily apportion the cloud cost to the budget that's been given to a particular department, you know? So there are cases where your company may mandate that every resource that gets created must be tagged properly so that when they're doing the reporting and they're searching for resources and they can drill down to know what resources are in use by what department, you know, these are ways in which those things get done, okay? But for the sake of our learning, we'll just stick to key value for the name to identify this. So let's create this second subnet. And what we're going to do is we're going to create a second public subnet, which will then be in a second AZ, which is the B. And then we can then say, so obviously it won't be, actually, let's do it this way. So this can be 2, 0. Then so that the 1, we can put it here, and then this one, 0. So that we can be using the number in the middle to separate them. So this is 1, this is 2. Okay. And then we create another one. Now, the fact that we name this public does not mean it is public now, because if you notice, they're being created the same way. Okay. So
you forgot to label the name of the second subnet. You still gave it public subnet 1.
Yes,
Change it to 2.
So for that. All right. So MCC public 2, yeah, that's it. Thank you. And then the third one will be MCC, and this can be private. But this is where the proxy is going to live. So we can just name it private proxy, but that's where Nginx is going to be. So private proxy 1. Okay. And then that will be in A. And then we can do something like this, copy that. So there's going to be a lot of copy pasting. And then the name has been configured as we want. That's fine. So let's create a new one. That will be there. Okay, that looks good. Let's create another one. So this one, for the next one, this is where the actual applications are going to be deployed. So this is an auto-scaling group that will hold one set of application, another auto-scaling for another. So if you want to have multiple applications, this is where that's going to happen. Okay, so we can then name this compute to represent that compute resources are going to be deployed in here. All right, so if you like, you can make the size of the network much bigger than 250. What's that number again? 256. So if you feel like you need much more applications and it's going to be beyond that, then you can play around with the figures and get a much bigger CIDR. But in our case, we know it won't be more than 250, so it's fine. All right, and private compute 2, that's fine. So do we already have private compute? No, private compute 1. Okay. All right, so let's create the second compute subnet. So private compute 2 in the second availability zone. And then we can have a 6. Private compute 2. That looks good. So we have 2 more, and that will be the data layer.
I don't know. When we did our own in the class, we used 6 subnets in total. So I don't know if you're creating more.
So, I mean, it's...
You can go to the diagram and check.
Yeah, so what you did yours, you probably had the data layer in the same subnet. So
no, we had 2 public subnets.
Okay, or maybe you had the proxy and the compute together. So in this case, I've just decided to separate compute from compute. Right?
Okay, because we had Bastion and
the proxy with the
Nginx
in
Explorer.
the public, I think.
Okay,
Yeah, in the public.
you have proxy with the public, yes. So, I mean, it's not like you've done anything wrong. At the end of the day, it will still work for you, but this is just to tell you that you can design your infrastructure however makes sense to you. Because you may then think about it and say, my proxy is in the public subnet, right? What if someone hacks into the public subnet? Because someone coming from the internet can access the public subnet. And if someone is able to get a hold of your proxy, they may be able to make changes to the proxy and then route your traffic rather than going to your application. It goes into a different application entirely, things like that can happen. So you may initially deploy your infrastructure like your version 101 and consider these as version 2.0 to say, okay, we revise our infrastructure. Now we feel like, to be much more safe, we need to move our proxy into a private network and do whatever makes it work. So these are kind of changes that get to happen, because the fact that you deploy an infrastructure the first time does not mean it's going to remain like that. Some businesses, you have compliance and you have people that will come in and evaluate your infrastructure, and they will tell you if you are not compliant enough. They can tell you where your security loopholes are. And in this case, it might be a case where such things have been identified, and now you need to go back into your infrastructure and redesign it and improve it for much more compliance. So it doesn't mean that what you did previously will not work. It will work, but it's just a matter of you now understanding, that there are different design patterns that you can introduce from time to time, and things like that. So this is a good example of that. Okay.
Yeah.
So now the seventh one, private data. What did we have before? Okay, we had compute. So private data 1, and then the first AZ. So let's get this number. And we can create the last one. All right, so I think everything looks good. So what we can do is just hit the create button, create subnets, and then it'll create all the 8 subnets. Okay, so now we can have a look at all the subnets that have been created. So from here, we can now start deploying resources into each of those subnets. So let's see what's next for us. Okay, so it says create the internet gateway. So that's very straightforward. So we can go back into our console and find the internet gateway section. And we do understand, so there is an arrow that I've put in here. The internet gateway allows inbound and outbound traffic from the internet. Okay, so what we're going to do is we're just going to create that internet gateway. Where is it? Okay, this is it right here. So it's just something you create, you put it into your VPC. It basically means you can use it to access in and out of your infrastructure. Okay, but for it to be used, you would then have to create a root table and then configure the root. Okay, so let's do that. So internet gateway, let's create one. So we can call it MCC-IGW, which is internet gateway. So we give it a name, key value, all right, and then just create it. Okay. Okay, so now you can see it's just been created, but it's not attached to any network. Let me see if, as I say, so let me update this note so that we can have it. to be updated. Okay, 1 second. I'm just going to bring it up. So after the class, what I'm going to do is I'm going to, so all the updates that is here, I will send it to you, but let me see, attach, maybe it's somewhere down below. No, it's not. Okay. So what we're going to do is after we've created the internet gateway, we need to attach the internet gateway to the VPC. Okay. All right. So let's refresh this just to see that. Okay, so you can see the state is detached. So it's not used. It's useless right now. What we've just done is we've created a resource in AWS and it's just there. Okay. So we need to attach it to a VPC, and the VPC we're working with is MCC. And then we can click on the attach, and now we can see that it is attached. So now this internet gateway is now part of this network. So we can reach this network from the internet, but how? So the how is what we're going to have next, which is create root table for the public subnet to use. Let's go ahead and create a root table. So root table, where is it? Okay. So create root table. So let's give a name, MCC root table. That's not how to spell root. Root table. So what's VPC? We want it to be in the MCC VPC. So it has its key value in the tag section. And we create it. So this root table is just like creating a table. It's just like a container. You've created something that is now about to hold stuff. Okay. So the next thing says create a root table, create a root in the public root table and point to the internet gateway. So we now need to create a root, okay, in the public root table. All right. So there is a section here that says, okay, edit root. So in the same root table, because if I go to the list of root tables, the one for MCC is what we're interested in. And you can filter, if I just type MCC, it will bring back the root table we just created. So if I open it up, you can see this section that says edit root. So now we need to add a root so that all the traffic can now go to the internet gateway. Okay. So we've updated the root, so you can see we now have, all that going to the internet gateway. So we can now do subnet association. So we need to do an explicit association to say, okay, all the public subnets will use this root information so that any resource we put into the public subnet will then be able to access the internet. So if I edit the subnet association, what I'm interested in is the public. Let's see if I can filter by public. So MCC 1 and 2, save associations. So now, if I go back to subnet and filter by public, let's see, filter by MCC as well. Oops. Okay, let's go back. So MCC public. Okay, so these two have now become public subnets because they were created the same way as the private ones previously. But now that we have done an explicit association in the root table to these subnets, they have now been considered as a public subnet. So if we deploy any application, any server into this subnet, we should be able to reach it. Okay, and that's what we're going to be doing. We're going to deploy an application, a server here, which is considered as the bastion or the jump box, which we will then use to access our private infrastructure. Okay. All right, so let's go back to our notes, see what next we need to do. So associate the public subnets to the root table, we've done that. So now we need to create a NAT gateway so that servers in the private subnet can reach the internet, for example, to download stuff. So that's the outbound. We talked about it last week as well. So when we have all these servers here, if we need to do apt updates, apt install, yum install, whatever, all those things, we need to make sure that there is a way in which those servers can reach out to the internet. And we also talked about an alternative strategy. If you don't want to do that, you can actually have another server in the public subnet, which will be considered as your, I'm thinking of the right word to use, but it's just like a web server that you can initially download stuff to. And if you want to download things, rather than go to the internet, you're actually going to that server to download stuff. But that can come with a lot of overhead because obviously you need to download whatever you're ever going to need will be downloaded in those servers. It will be scanned, quarantined, and anytime you want to download something, you always have to go there. The problem with that is, when you do apt install, apt takes care of all the dependencies. So some dependencies that you're not aware of, they will be missing from your staging server there. So every time you try to download something and you have errors, you have to then go to the internet, get the dependency, put it there, try to install again. Now that dependency may have its own dependency and it can keep on going on and on and on like that. So you're able to get to the last and you get everything there. And that would always happen anytime you want to introduce a new package into your infrastructure. You have to be able to bear in mind that headache, that overhead is going to be there. But to start out with, you obviously don't want to give yourself that much work. So you can have a NAT gateway, which basically gives you access to the internet. The good thing with that is anyone from the internet will not be able to reach directly to your private servers. So let's quickly create the NAT gateway. So still in the VPC section, there is going to be the NAT gateway section. So that's the NAT gateway. So we can just click on the create NAT gateway. And then we can give it a name as well, MCC NAT GW. And then we now need to select the subnets. So this is going to be, in the public subnet. So let's put it in the MCC public 1. Okay. And then the connectivity is going to be public. And we need to have an elastic IP. So an elastic IP is that, okay, let's start with your experience when you were creating servers, especially when you started with your project 1, project 2. You create a server, and the moment you turn that server off, the public IP that you use to connect to it goes away. It gets released. And every time you bring it back up again, a new public IP will be assigned. And that can be a lot of pain because it's not consistent. So to have a consistent IP, you will turn to something like an elastic IP address. And then you get the IP address, you associate it with your instance, and that way it would always remain the same. So when you turn it off and turn it back on, that IP address remains the same. But it comes at a cost. Initially, it was, I think, AWS was charging about $5 a month when they started with this elastic IP. But nowadays, it doesn't actually cost you as long as you're using it. So if you create an elastic IP, if you associate it with a server, AWS will not charge you. But if you don't associate it, that's when they charge you. So it's a bit of, it's a funny situation. It's like saying, if you use this resource, we won't charge you. But if you don't use it, we're going to charge you. Okay, so well, we want to use it for our NAT gateway. And the reason is because our NAT gateway needs to have an IP that is static so that it won't be, because what a NAT gateway does is it does network address translation so that, let's say you want to download something from the internet and the server that you're downloading it from, it needs to be able to return the message back to you. You know, whatever packets that you're receiving, it also needs to send it to an endpoint. So the endpoint is going to be sending it to that place you're downloading from is aware of is going to be that elastic IP address, because that endpoint is not aware of your private servers. You say this 10.0.3. whatever, it is not aware of it because these are private IPs. So it is the public IP that is reaching out to that endpoint that is going to be known. And that IP address has to be static, and that's why we need to allocate an IP address.
Sorry, Mr. Dari.
So, yes.
Can I ask you a question, sir?
Sure.
Yeah, sorry, I had an interview like last week or last 2 weeks, and the question was that if you deploy an infrastructure and you later discover that you need more IPs, how will you generate the IPs? I don't really know if that question was okay, because I was kind of confused about the question.
So, I mean, what they're asking you is a situation where when you started designing your infrastructure, as you can see, we're creating 10.0 whatever /24. And let's say over time, they now started having a lot of IP addresses. It became a situation where anytime they want to create new servers, they're getting no more available IP address, you know, just because you've exhausted what is available in your subnet. So what they're asking you is, in situations where things like that happen, how do you deal with it? Do you destroy all your infrastructure and then recreate everything? Well, unfortunately, that's what happens, because it's very important to plan your infrastructure properly before you start, you know, making all those kind of decisions. Any shop that finds themselves in that situation, they would have to start thinking of ways to offload some of their resources into a different place, and then recreate the subnet, give it more IP addresses, okay, and then bring back the infrastructure. That's one way. Another way is they can use, now there's something called a secondary IP address. Now, even with that, it's not going to work, because that secondary IP address is going to use from the pool that they already have. So it's usually a pain when things like that happen, and that's why it's very important that, you know, planning out the infrastructure from the start is usually very important. So the best way to go will be to, first of all, ensure that you have planned out in the first place where you don't find yourself in that situation, or you can then redesign your infrastructure and create new subnets. So if you create new subnets and you expand your workload so that, you know, for example, when you're designing, we're using 2 availability groups, right? You can begin to use a 3rd availability group and then create a new subnet that will now have much bigger IP addresses, so that when you're auto scaling is now scaling, it can go beyond what is available. So those are the kind of things, but it's usually better to ensure that, you know, you have a proper design right from the start.
All right, thank you, sir.
Okay. All right.
Hello,
So,
Mr. Dari.
yes.
So I wanted to chip in on that question. I'm sure we didn't touch on CIDR, but I'm thinking in a case like that, could VLSM work?
VLSM.
Yes, variable length subnetting mask. Could that work?
Well, it's now that's not something I have a lot of knowledge around. And in most situations, you would have network engineers working as part of the team. It depends on how big the organization is, because in some cases you work with companies where they have separate network teams. You have, people looking after the infrastructure. And if you have a network team that understands how things like that, VLSM, which I think is like virtual networks, you can create virtual networks which will have their own IP CIDRs that can extend
it's not actually virtual network. It's variable length subnetting masks.
Okay, that's not something I have familiarity with. I haven't worked with that at all. So I won't be able to tell you whether it will work or not. But what I think might also work is in virtual IPs, if you have the capacity to use virtual IPs, because that's another thing that's could be thought about. But again, one of the things that happens a lot is spikes. So when you are in a situation where things like that are beginning to happen in your team, then your team can decide, say, okay, we need to do a spike to understand how this problem can be solved. So that's where you now start doing engagements with network engineers, people who are looking after the infrastructure, or you do your own research, and then you can do proof of concept. So you can simulate situations where your IP addresses are getting expired, or the limiting no more IP addresses. And then you can do proof of concept. If you're thinking of VLSM, as you've mentioned, and you've never worked with it before, you can simulate a proof of concept and test that. It's not something that I have touched on or that I've done, so I'm not going to be able to tell you whether, yes, it will work, or no, it won't work. I don't know. But again, if you're curious about that, you can do proof of concept around it and then, try it out. Okay. All right. So now we have the NAT gateway, okay, in the public subnet one. And by the way, you can create the NAT gateway only in one subnet. Now, NAT gateways are expensive, so you have to be aware of that. So in this situation here, you can see there's only one NAT gateway here. It's possible to have another NAT gateway in this other subnet in another availability zone, but bear in mind that it's just going to be redundant, because it will only be used when there's like a failure, but maybe this one is not working and things like that. So this is definitely a single point of failure, but again, it is a software as a service. In most cases, it works fine. Okay, so even if you have just one here, it works fine. But the only problem you would have is when this whole availability zone is not available, then you don't have this NAT gateway. Okay, so if it's something that you're going to need a huge availability for, you want to make sure you have a copy in the second subnet, so availability zone. But in this case, we've created just one. So if you're going to need two, then you have to create a second NAT gateway. Okay. So it takes a bit of time to provision. So initially you see the state to be pending, and then over time you get to see the IP address, the private IP, and all that. So if we go back, so we can keep an eye on that and see when it becomes available. All right. So the next thing here says create root table for private subnet to use so let's create the root table, and then we'll create roots so that we can use the NAT gateway. So let's go back to the root table. And then we'll say MCC, we can call it private root. Okay. And then that's going to be in this MCC VPC. And then we can edit the root, but let's see if the NAT gateway is ready. So it's still pending. Let's see if we can access it here. Okay, so it's there anyway. So let's just create it for now. When it becomes ready, then it will show up there. Then we can do associations, so subnet associations, edit the subnet association. Then we can select the private subnet that needs it. So we know we're going to be downloading stuff on the proxy subnet, on the compute subnet. So we only need these two subnets. You know, the RDS is going to be managed service, so we don't really need that. And it's our data layer. We need to keep it more secure, right? So let's just filter by MCC. So all the MCC. So we don't need for data. We need for compute. We need for proxy, private proxy, and compute. Okay. All right. So we're getting there. We're getting there. So we've done our NAT gateway, we've done our routes, and we've done the routing for the NAT gateway. And then associate public. So we've done the associations as well, right? And then it's now time to start creating subnets. So this is where we have to pay a bit of attention, because creating our security groups is more of defining our firewall rules to say, okay, who has access to what? If a certain resource does not need access to another resource, then there's no point opening up firewalls to it, basically. So let's see from our notes. Let me drag this here. Let's see the first one. So the first one, so we're starting from number 11. So it says create security group for Bastion. So we need to allow all DevOps engineers to connect over SSH to the Bastion server. So what that means is we have this Bastion server here, and for a DevOps engineer or any developer or whoever needs to access our servers over SSH, they need to jump onto this box first of all before they can then SSH into any of the private networks. So that means we need to create a security group that opens up SSH on specific IP addresses. So let's say, for example, you join the DevOps team. Say, okay, cancel that. We can sort that out later. Anyway, so let's say you just joined the team, and the team is very specific about who has access to the Bastion server. So you can try to put canhazip.com on your browser. So I'm not going to hit enter, otherwise you'll get to see my public IP. But you can try that on your own. Just put that. It gives you the IP address of your home network. And then you can go to security group. Where is it? Security groups. And then we can start defining the firewall rules. So let's create the first one. So we'll call it MCC SSH to Bastion, something like that. Okay. And then the tag, let me just quickly give it a name, because this one you have to type it manually, unlike the VPCs where as you're creating the names, it populates it yourself. Okay. All right. So allow SSH access to developers. That's what they have written there. So in our case, allow SSH access to DevOps engineers. All right. So the VPC here is going to be the MCC VPC. And then what's the inbound rule? So we need SSH on port 22. And then if you want my IP, even if you don't do canhazip, you can select this my IP, and then it will populate your IP address. And then it will be people specifically that you want them to access it that will access it. So if there are multiple DevOps engineers on your team, even if there are 50 of them, you have to keep adding the rule. Now, the good thing is you're going to be automating this. So it's not going to be a case where you come onto the browser to click and do things. Writing this in Terraform makes a lot of sense, and you can do, simple configuration that would dynamically add on the IP addresses. So you join the organization, you give them your IP address, they add it there. Or it may be a case where it has to go through certain VPN that has been configured. Whatever the situation is, your organization will let you know that documentations are shared with you. But this is simulating a situation where you have to provide your IP address, and you would only access the infrastructure from your home network. I used to work with a company where I couldn't even travel just because of this. Because the moment I travel, maybe even within the UK, if I go to like a hotel or whatnot, I can't access the infrastructure. It has to be specifically from the IP address that I have provided. So it depends on how secure, the company wants their infrastructure to be. Things happen. You join companies and you get to see a lot of things, different things, funny things, actually. Okay, so in this case, I'm just going to say, from anywhere, maybe we're just not too concerned about security. But I'll say from anywhere, just because, we're building this together, you guys will also be able to access this. And then outbound rules, most of the time, this is not something that you find people really configuring, because you want to be able to go outside from the server. But if the requirement says it has to be to specific endpoints, then of course you have to come here as well and be much more granular. So if the requirement says, well, you can only SSH out of this server, no other protocol, then obviously that's what you have to do. Okay, so just for simplicity, we'll leave all traffic. So the same thing is just about the firewall rules, what comes in, what goes out. Okay, as long as you know what you're doing, that's fine. Okay, and then we have the tags, and that's fine. So this satisfies the security group firewall, so that when we start creating this server, we can then associate that firewall rule to that server, and it will take effect. Okay, all right. The next thing is we want to create security group to allow the entire world to talk to the load balancer. So you can see here that our customers will come to the domain, and this domain is going to have some DNS configuration that routes to the load balancer. Okay, because the load balancer would have some long, funny address, and that's not what you want to be giving to your customers. So you're going to have an address that people can remember, it's human readable, and that will be routing to your load balancer. And so who's going to have access to this load balancer? Obviously, it's going to be all your customers. So if it's a startup, that it's a company, it's a worldwide based thing, you want everyone to have access to it, then you can create your firewall rules as such. So anyone, anywhere in the world can access this load balancer. If it's a service that will only be accessible to people within your company or within certain networks, it's possible you want to restrict access to your web service to only certain people. Maybe the service is only being provided to another organization, and you only want people from that company to access it, then they will have a CIDR range that they'll provide to you, and you're only restricted to that CIDR. Okay, so that's what this is all about. So we'll create security groups for that as well. So let's go back to security group, and then we can say MCC, this is going to be HTTP. So let's just say HTTPS, because we will ALB, because we'll implement HTTPS. Okay, so to ALB. So ALB is the application load balancer. So allow traffic to the application load balancer. And then the VPC is going to be that. And then the rule, we can say all traffic on only, anyway, actually, maybe we could just say HTTPS only rather than say all traffic. So we want HTTPS only on 443. But because initially we're actually going to configure HTTP before we do HTTPS configuration. So we can just have both HTTP, HTTPS, okay? And then later on, maybe as we go along, maybe this first release, HTTP and HTTPS, later on after initial release, we can then make sure that only HTTPS is going to be the traffic. When we start doing a lot more on CI/CD, you would get to appreciate things like version 1, version 2, you know, all those different kind of releases. Because releases is not just about applications. Because we're going to be having infrastructure as code, and a lot of the things that's happening with our infrastructure will be driven by code, then it becomes, it makes more sense that we can also version our infrastructure, and we know what version of our infrastructure is running at every point in time. Again, because there will be CI/CD pipelines for infrastructure, for every element of the infrastructure as well. You know, at some point down the line, depending on how deep you want to go in terms of your DevOps journey, you also start touching base on GitOps that ensures that whatever infrastructure you have in the cloud is the same as what you have in your Git repository. And it's always in sync, so that even when you do manual configuration like this in the cloud, it triggers some processes that ensures that your Git is updated to whatever drift that has occurred in your cloud infrastructure. So, but all of that, we'll get to touch on them later. Okay, and then let's create a name tag and just get the name here. All right, so I guess we're good. Outbound rules, that's fine. We can just leave it at the default and create that as well. So that satisfies number 12. So if we go back into the console security groups built up by MCC, we can see we've created 2 security groups so far. So we'll get to create the rest of the security groups. So create security group and allow ALB to talk to the Nginx server. So our infrastructure, what's going to happen is when the traffic hits your DNS and it reaches your load balancer, now your load balancer has to talk to the Nginx proxy, because that's where the proxy configuration that goes to other applications is going to be. So that means this traffic flows down like this to the Nginx proxy. So that means we want to restrict our load balancer. We want to restrict access to this Nginx only from this load balancer on HTTP, HTTPS protocol. Obviously, remember, there's another security group we will have to open up, inbound rule for Nginx, because we want our bastion to have access over SSH. We also want the load balancer to be able to access it over HTTP, HTTPS. So let's get that done. Okay, so we have HTTPS, and then we can do SSH. So now we can start making different images. So from ALB to Nginx. The reason why your naming is important is just because these things can become very messy, especially when you have a lot of security group and rules and all that. If you don't have nice ways of naming them, that makes it easy for you to identify. When you're doing troubleshooting, it can become a lot of headache. So that's why I take diligence in naming all these things. Okay. So the first rule is SSH. And where is it coming from? Well, it's going to be custom. And let's see, let's type in Bastion. Okay. So you remember the Bastion security group we created earlier on? So let's select that. So that means this SSH, where is so that means this SSH access is going to come from this Bastion. So even though we haven't created this resource, the fact that we've created the security group we can select the security group so that when we start creating this Bastion resource and we attach that security group to it, when it's time for it to go to this Nginx is going to evaluate the rule that says only allow SSH from the security group that belongs to this Bastion. So that's why that's going to work. Okay, so it's custom. We've selected the security group ID of the Bastion, and that will make it work. So optionally, you can put a description here so that, because what you're going to be seeing here is just an ID. So if you don't have a description, it can also be a lot of headache trying to troubleshoot, and you're trying to figure out, oh, what's this rule for? What is this? Where's this coming from? So this is really important that you get to put descriptions in these things. So let's say allow access to Nginx from Bastion. Okay. All right. So the next rule is we're going to have for HTTP. Okay, let's get a HTTP. And then this is coming from the ALB. And remember, we had the ALB. So MCC HTTPS to ALB. Okay. So this is the one that's coming from ALB. And then we can put the description as well. Allow access to Nginx from ALB. Then we can do the same for HTTPS. Okay, so ALB, that, you can just put the same thing. And you can do allow HTTP, just to be a lot more specific, allow HTTPS, allow SSH. So this way, it makes more sense. You come here, you look at it, even though you're seeing all these IDs, you know exactly what's going on. Okay, and this can be messy, trust me, because you can have a lot of rules. So you don't want to give yourself headache. So let's copy this and use it for the name tag. And we can put description. We can just make it a description as well, just for completeness, and create that. So this looks good. All right, so let's go back to our infrastructure. So we've taken care of this, we've taken care of that. And going through this exercise of creating the security groups and all that, it makes life easier for you when you start implementing, because you just now understand how your infrastructure flows. Okay. And by the way, guys, one of the things you want to do is to don't look at this infrastructure and think it's perfect. Once you have implemented it, you now understand logically how things work, how things flow, how things, these resources, what they mean, what they do. Start thinking how to fault this, fault it, give yourself projects, give yourself work to do. When you think about it and then you try to fault it, then implement a proof of concept. When you do that, you've acquired an experience. Like someone was talking about the what did you call that thing again? The extensible network, LC, sorry, pardon me. You can try something like that. That's how you implement projects. That's how I started my career. I started thinking of projects to do, okay, and I started doing them and documenting them. So even if you don't have experience, you can build and create experience for yourself. It's all about going to interviews and be able to talk about things you've done. So experience is not just about working for an organization and having a way to prove it. No, experience is also about what what you've done, what you've, experienced. That's experience, isn't it? Right? So yeah, so that's just a passing comment. Always think about this, compare this with other, because AWS have what they call reference architectures. So if you go online and type in AWS reference architectures, there's a whole lot of architectures you can see online. So reference architecture examples and best practices. So you can search for architectures based on different use cases. Okay, I think it's still loaded. Yeah. So if you look at this, you can then begin to filter and say, okay, I want to think about, let's say, compute and maybe containers, and then you see architecting for HIPAA security compliance on Amazon EKS. When we start working on EKS, you get to know more about these things. Implement a serverless pattern, design login, monitoring, VMware cloud solution. There's a whole lot. If you're interested in, blockchain, for example, there are architectures. So let's have a look at an overview of the AWS Cloud Adoption Framework. Don't know if that's an architecture, but let's open up this one. And then you'll be able to see some of the designs. No, I'm looking for proper diagrams. Okay, let's see patterns. Let's remove this. Reference architecture diagram. Okay, yeah, that's what I'm looking for. Okay, let's see. Implement a satellite mission framework. Let's just take one, for example. Let's see. Okay. So you can read some of the requirements, go through some of the diagram. There are some that actually does have a lot more verbose diagrams, like something like this. Just take your time, go through this reference architecture page and just filter through and try to explore and read about different use cases, okay? And then begin to implement projects based on yourself. That's what I did, when I was starting out, and it helped me a lot. So don't just take one diagram from a training platform and think, oh, I've arrived, I'm ready. Even though we'll present you with a lot of diagrams, there's still more ahead, but you also have a lot of work to do, okay? All right, so where are we? So we did ALB to talk to the Nginx proxy, right? That's number 13. So number 14, we're saying create external facing ALB. Okay, so we're still going to create more security groups, but I guess we just need to go and start creating some resources and make use of some of the security groups we've created. So we don't get bored just creating security groups all day long, okay? So let's do that. So create an external facing application load balancer. So let's go to, so we're going to go out of this VPC section and go to the compute section. So if I type compute, it doesn't come up here. Okay, so let's type EC2. Okay, let's go to the EC2, virtual servers in the cloud. So in the VC2 section, just like we had for VPC, you can just minimize all this. You can see there's a load balancer section. All right, so let's go to load balancers. And then we're going to create an application load balancer. So you'll be presented with this page that tells you, well, there's application load balancer, there's network load balancer, there's gateway load balancer, which is relatively new. What we are interested in is the application load balancer. So it's important that you understand the differences between these load balancers, and understanding it is also understanding the layers of networking, because the application load balancer is on the 7th layer. And for those who are from network background, you understand what I'm talking about, the OSI layer. This is on the 4th layer. Now there's a video, I'm going to find that video. It does a fantastic job explaining the OSI layer. For some of you who've watched it, you can confirm that it's some Indian guy who explained it using military camp on how communication pass through, how data packets go through, and the layers, and the way it was explained was so fantastic. So if you haven't watched that, remind me so I can send it to you on Slack afterwards. And I think it's just about 20 minutes video, and that would do a great job explaining to you the differences between these layers of networking. But basically, we are interested in the application load balancer. It's on the 7th layer, and it works on the HTTPS level because we're trying to talk to applications. Okay, if you were trying to talk to servers directly, with IP addresses and all that, you'd be considering this network load balancer. Okay, so now there's another one called the classic load balancer. That's the previous generation. For those who started with AWS, when they started many years ago, what they had was the classic load balancer. They didn't have all this, but this is now old. So if you're creating new applications, you want to consider these new ones. The only time you'll consider classic load balancers is when, for example, what you're trying to do has some dependencies on the old generation that it just can only work with it, okay? Or your requirement just doesn't satisfy any of these, okay? All right, so we'll create an application load balancer. We'll give it a name. Okay, so let's call it MCC AL public ALB, because we're still going to create one that is internal, but this one is going to be internet facing, because that's the one in this diagram that is facing the customers. Okay, so we're creating this ALB. All right, and now the VPC, we have to select the VPC that this is going to be. And then we're mapping it to our subnet, but not the private subnet. It has to be the public subnet. So you can see that's why I was throwing this here, because it has to be mapped to the public subnet. And then the security group, remember we had already created security group for this. So we're going to cancel this default out. So ALB, so MCCP, HTTPS to ALB. Okay, so not this one. This is the one that goes from ALB to Nginx. And you can get to see now the whole essence of making sure that we give very good naming conventions to the naming of our resources. Because just looking at it, you can easily tell, oh, this is what I need to select. Okay. And then now this whole listening and all that, well, let's see whether it's part of our plan yet. Okay, create external facing. Okay, create a listener on port 80 and target group. And then, okay, so let's go back. Now, we need to create a listener, and we need to ensure that this listener, when it's been evaluated, it forwards to a target group. So let's use this time to talk about listeners and target groups, okay? So first of all, let me go back to this EC2 section. And then let's go to our diagram. Now, when our customer is trying to talk to our service and is routing to the load balancer. So this IP address you're seeing there is just a simulation of the load balancer IP, saying it's resolving to the load balancer IP. Most case, it's not going to be an IP, it's going to be one long name. Now, this load balancer, you can access it. When you go to Dare.io, for example, and you hit enter, what's happening is the browser is going through a port. So even though you don't specify the port, because it's on HTTPS, by default, HTTPS listens on port 443. So this is what happens. So it's going through a particular port. Okay. Now, let's talk a bit about, ports, port numbers and IP addresses. Think of an IP address as a building, a house. And then the ports are the windows. So if you come to a house and let's say the front window has number 80 and you have a back window that has number 443, what it means is you reach that house, which is the IP address of the house, and then you go through a certain window to get in. So what I'm trying to say is this diary.io resolves into some IP address. But the question is, on what port, which window am I passing through to get into the house? So that's what this is all about. So if you're now configuring your listener, it's possible for you to configure your load balancer to listen on certain ports. You can configure it to listen on port 231, port 8080, whatever port. But because we're using the HTTP and HTTPS protocol, they have their default ports. And that's why we don't get to specifically specify those ports when we go to our browsers. The browser understands that if you're going through HTTPS, it's going to be listening on 443. If you're going through HTTP, it's going to be listening on port 80. So for that reason, we have to configure the load balancer to listen on a particular port. Once you hit the request and it goes through that port, then the load balancer needs to understand, what do I do with this request? Who do I send it to? Okay. And in this case, it has to send it to the Nginx, but we now have to put this Nginx into a target group, because that's how it begins to understand that when we have multiple Nginx servers running in an auto scaling, how does it know that it needs to send the traffic to this one or this one or this one or that one? Well, the way it's going to work is it's going to create like a container called a target group, and it just sends it to that target group. So once it gets to that target group is going to only have healthy Nginx servers running at every point in time. So once it gets there, it just sends the traffic to anyone and they can all respond to the request because they're all running the same thing, the same configuration. It doesn't matter which server it hits, they're all going to work the same way. So that's what's going on here. So that's the reason why here in our notes, it says in number 14 here, we're creating the external load balancer. But here, number 15 says, create a listener, port 80, and the target group. So what we're going to do is, so this is the part where we need to create the listener. So we're going to create a listener port 80, and we have to forward it to a target group. So you can hit on this button here, it will open up a new tab to create a target group, and then we'll come here and select it. If I click on this now, you can see there is nothing to select because we don't have any target group. So it's either we hit on this, but I won't hit on that one. I'll just go through here so you can see where we can create the target group. So let's see. I think it's okay, this is it. So under the load balancer section, we have target groups here. So if I click on that, I can create target group. Now this target group, you can configure it that it's, when your listener from the load balancer receives the traffic and sends it to the target group, the target group can be configured based on instances, based on IP address, Lambda functions, load balancers. What we are going to be using is the instances. As you can see here, it has some notes that they've written there, support load balancing to instances within a specific VPC. And that's exactly what we want to do. So we're going to put some instances in there. I mean, imagine if, let's say, you wanted to route the traffic to some IP address. Maybe those IP addresses are running in your private data center, your private infrastructure. It's only going to be aware of those IP addresses and not instances. But in this case, we want to work with instances directly because these are going to be part of auto scaling, and we don't even know ahead of time what their IP addresses are going to be because it's going to be dynamic. So we'll leave this option right there, and then we give it a name. So MCC, this target group for Nginx. So very important, always give a name. Naming convention is very key. Then we'll select our VPC. Okay, we can leave the protocol to be HTTP1. If we select HTTP2, it says send request to target user HTTP version 2. It's supported when the request protocol HTTP2. So basically, only when the request itself is configured to use HTTP2. But if you send it, if you use this HTTP1, it will use both HTTP1 and 2. So more like a backward compatibility. And gRPC is another protocol entirely if your application is developed based on that. So we'll leave it at HTTP1, and then we have to configure health check. Now, health check is very important here because your auto-scaling group will always ensure that you have healthy instances at every point in time. You don't want a situation where a traffic comes from your customer, hits your load balancer, and then your load balancer tries to talk to the auto-scaling group. But one of your servers is not healthy. Maybe for whatever reason, it's running, but it's just not fine. Imagine if your auto-scaling does not kick it out. That means your traffic will hit it, and then your customers will not be happy because it will render some error back to them. So auto-scaling group has to ensure that at every point in time, it is only healthy instances that will be there. And that's why you have to configure a path that will be checked every time, such that if it doesn't return a response code, it understands that it is not healthy. And because it's not healthy, it kicks it out and then tries to provision a new one. So that's why you can do that. So you can configure anything you like. You can just put it like that to show that, you know, the root on that file system has to always return 200. Or you can put a health path. That means you just create a file on the server. The naming convention used mostly is health and Z. I don't know why the Z is there, but you know, you see that. Another thing you might see is status. So if you have like a file on the Nginx server and configure the status, it means anytime you do a curl, you hit the Nginx server /status, it must always return a response code of 200 OK, which is what it is also configurable, because if I open up the advanced, what is the success code you expect to have? So the default is 200. So you can configure whatever as long as you get your server to return that success code. HTTP success code 200 means success. So there's no point, you know, changing this except you have requirements to change it. Or maybe your application returns a different code entirely to represent 200. That does happen sometimes. I've seen that happen. Okay. Okay. All right. So, so we can leave this as it is. What I'll do for now, I'll just leave this as the root. Leave that for now, because we haven't actually started creating any resources. We're just preparing things. And then the tags, let's give it a name tag. Name. Let's get the name. Can't remember what name. Should I copy it? I think it's MCC target group Nginx. All right, so let's create that. And for now, it's expecting some instances. We don't have any instance, it's fine. We just leave everything as it is. You know, later on, we'll start putting instances there. So this target group now exists. So consider this target group right now as just a container that our resources, our EC2 servers are going to be put in there by the auto scaling when we're ready. So if we go back to this and refresh, and then we will see that target group. So we can select that. So what this means is anytime we receive a request on port 80, it forwards that request to this target group. And this target group is going to ultimately, when we're ready, contain Nginx servers. So now you see how our traffic is going to go. This is going to flow down, hit the target group, and then goes to the Nginx. Okay. All right. So if we do the same for, so we've done for HTTP. So let's see if we can do in one go for HTTP 443 as well. HTTPS, we can forward it to the same target group. So yeah, that's fine. We can leave that. Now, if we want to configure, well, actually, I'll remove this HTTPS for now because we're going to start off first of all with HTTP. Because to do HTTPS, we'll have to configure certificates and all that. And we're not doing that yet. So, because that's why it was loading up the whole certificate configuration. So if I select this now, you will see it's asking us to, select the certificate. We haven't created a certificate, and I don't want to create unnecessary drama yet. Okay, so let's have that, and then we can create the load balancer. So view load balancer. So MCC public, so that's getting created. So you can see it's provisioning. All right, so let's go back to notes. Where is it? Okay, so that was number 15. So number 16 says create a launch template for Nginx. So we use a Red Hat based AMI so that we can provision the Nginx servers. So the way auto scaling works, by the way, let me confirm. Do you guys have questions so far? Do you want us to stop here and continue from here tomorrow? Are we already having information overload? Because I'm just going on and on and on. And I know these things can be quite confusing, especially for those who are going through it for the first time. So do you want us to spend the next 20 minutes and keep on creating resources? Or do you think there's information overload already happening?
Keep on creating resources.
Okay.
Since we have up to 20 more minutes, you can use up to 20 more minutes.
Yeah, good. So we can carry on. Awesome. Okay, so what we're going to do next is talk about auto-scaling group. Even though number 16 here says to create a launch template, what we're going to need is launch template for the auto-scaling group. So let's talk about this. So the auto-scaling group here is what is going to be creating our EC2 servers. So let's say maybe one of them gets created initially, and then there's a lot of traffic all of a sudden. Maybe it's Christmas or it's Salah time, and celebration is happening. Maybe it's an e-commerce site and people are buying stuff, and for some reason there's a lot of spike. And then there is need to provision a new server. Now the question is, how is the auto-scaling group going to know how to create this server? How is it going to know whether it's going to be an Ubuntu server, a Red Hat server? What tools will initially be installed on it? I mean, in this case, it's Nginx. So it has to know how to install Nginx and configure Nginx exactly how we want it. So how is that going to happen? It happens through what is called the launch template. So you need to create the launch template first, make the auto-scaling group aware of it, so that when it's time to provision a new server, it uses that template to provision the server, which is what we're going to be doing now. So we'll create a launch template first, then we create the auto-scaling group, and then we can have something going for us. So if we go to this console right here, if we go to instances, you will see the launch template section. And by the way, you may be asked the question, what's the difference between launch templates and launch configurations? Let me see if there's launch configuration somewhere, auto-scaling. So you can see this is launch configuration here. There's launch template as well. So they basically do the same thing, but this is old generation. So if you're creating new infrastructure, you don't want to use launch configuration, you want to use launch templates instead. And the major difference is that with launch template, you can create new versions of your template, okay, without destroying the previous one, which is what launch configurations do not have. So that means, let's say you create the launch template the first time and you want to change the AMI or you want to change something about it, you can create a new version of the same launch template and you can switch between the versions. For some reason, if you still want to use the old version, you can tell ASG to use the older version and not the new version, go back and forth like that, which launch configuration didn't have that. I don't know why AWS decided to separate them like that. They could have well just improved the functionality of launch configuration, but they've just decided to call it something else and leave launch configuration there. So we're going to be using launch template. And then we're going to create one for Nginx. So that means for every application that we'll be deploying. So in the case of our diagram, we have the Nginx, we're going to have our WordPress site, we're going to have our tooling site. Each of them will have their own launch template configuration. Okay. All right. So let's create a launch template and then we give it a name. So MCC launch templates Nginx. So LT is launch template. So template version description. So we can just copy paste this. You can put whatever you want. The example they gave is prod web server for my app. Let's just leave that. All right. Then auto scaling guidance, you can leave that because we're going to configure our auto scaling ourselves anyway. Well, one of the things that's most important you want to look at is how to select the AMI to use. So you know what an AMI is, which is the Amazon machine image. So that's like the template server that will be provisioned. So there's different templates we have for Windows, for Amazon Linux, Ubuntu, Red Hat. So our requirement here is to use Red Hat for Nginx. So we're going to select Red Hat. So we can just select Red Hat. And by the way, you can click on this browse more and search here. So you can see it's selected that already. So if that's what you want to do, if you want to search for something else, you can do that. Okay. So we've selected our AMI, which is Red Hat. And then instance type, you can decide which one you want to use. So I'm just going to go with the T2 medium. You can go with the free tier one if you like, but I know this is going to cost me. So be aware of this as well, that this can have cost implications. So you can start off with the free tier one. Sometimes it may give you an error to say, oh, this AMI does not allow free tier. So just play around, see what works. Now, we don't have any key pair, so we need to create a key pair so that to SSH onto the machine, we need to be able to provide an SSH key. So we can hit on this. Let me see if I can. Okay. Well, what I'll prefer to do is not hit on this. Rather, I'll prefer to just go in here and create my key pair instead. Where is key pair? Okay, this is key pairs. So let's create a key pair. MCC EC2 is just that. Give everything. We can give it a name tag as well. Create key pair. So I'm going to save this in my downloads. Okay. And then we can go back here and then refresh. And then now we can find our MCC EC2. So we've selected that. Then subnet. So which subnet is our Nginx going to be? So it's going to be in the proxy subnet. So it should have the name there. So proxy. So we can select private proxy 1. Okay, we can't select the second one, but that's fine. When we're creating auto scaling group, we can make it use multiple. So, but for now, for the launch templates, okay, select one. But when we're creating the auto scaling group, we can select both because we want it to be both. We want the auto scaling to be able to scale across the two availability zones, right? Okay. Let's refresh this actually. Okay, so this NAT gateway is now available, so we can close this tab. All right. Now, the security group. So select existing security group. The good thing is we've created security group. So let's see, well, what is it called? Is it Nginx? Okay. So HTTPS from ALB. So that means when our Nginx server is up, the security group that will be assigned to it will be the one we created earlier on, which means SSH will be able to come from Bastion, HTTP will be able to come from the ALB, which is exactly what we want. That's the only thing that can access it. Okay, so we're not doing any advanced networking here, but if we needed to do like secondary IPs, or we want to be able to create multiple network interfaces, those kind of things, you know, that's what's going to happen here, but we don't have any requirements for that. Storage as well.
Sorry, please. Sorry, please. Sorry to butt in here. In project 15, we checked the one and the checkbox form enable auto IP addresses. What was the point in doing that there?
Auto IP addresses for which of the resources? Is that for the Nginx? Or from where?
Yeah, yes, for the yes, and for the for the Nginx.
For both Bastion and Nginx, because
we
are
for the ALBs, yeah. We checked enable them.
Yes.
For ALB or for what?
It was for both Bastion and Nginx because they are placed in a public subnet. So the architecture is different from your own.
Okay, so what I want to understand is it when you're creating launch templates or when you're creating the VPC or subnet? At what point did you
launch template?
Okay. Okay, so is it from the advanced network configuration?
Advanced, yes.
Okay, and where is the option here?
On the right there. There it goes. Assign auto assign public IPs. Right
okay,
there, that one.
auto assign public IP. Okay.
But that was because, sir, that was because both the Nginx and Bastion was in the public.
Yes. So
that was
remember we talked about this architecture, which is slightly different.
Oh yes.
Yes, this was in the public subnet, and now we've moved it to the private.
Okay.
Because if you think about it, it makes your application a lot more secure, because that means in the public subnet, there's nothing here that has to do with your actual application. Not even the proxy is in the public. Everything is now in the private. Okay, so the more you're able to secure your infrastructure, the better.
Yeah.
So that's why now enabling auto assign public IP is not relevant here, because it's in the private network. Even if we select this here, it's not going to have any effect because there is no public IP, there's no public interface for it.
Understood.
Okay. Yeah. All right. So so we leave the advanced configuration as it is, and then storage is fine, 10 gig. If we had more requirement for more, by all means, you know what to do. That's where to do that. And then resource tag, we just create our name tag here. This is launch template, right? So MCC Nginx launch template. No, I think we put launch template here. MCC LT Nginx. Yeah, cool. All right, resource tags were there, and the types instances. That's good. Let's see, what advanced details do we have here? So this is if we wanted support instances. That's not what we're using here. When we start working with Kubernetes, we have requirements for spot instances, so you get to see how spot instances work. But for now, we're okay with the default configurations, and we don't have to do anything. But we do need to put user data actually. So allow tags in method data. Okay, so this user data here is where I was talking about that when this launch template is being used to provision the servers, how does it know what to do, what to install and all that? So this is where you can now put your shell script and it does that. But to simulate that launch template versioning, I won't put anything here. We'll come back and put it there, okay? So let's just create it first of all and see what happens. Okay, so we have the launch template. So the next thing we're going to now do, so we have our launch template here. So the next thing is to create the auto scaling group. Okay. All right. One second, I'm just looking for something on my laptop. 1 second. Right, okay. So let's create our auto scaling group. So create auto scaling group. Let's give it a name. And this auto scaling group is going to be for the Nginx, yeah? So AMCC ASG for Nginx. And then which launch template do we want to use? This MCCLT Nginx, the one we just created. And you can see it's loaded all of that for us. Everything we've configured from the launch template. You can see the AMI ID. It's not picking up the security group, but that's fine. I guess we'll be able to do that next. So here we can now select the VPC. The subnets is going to be the private proxy 1 and private proxy 2. Where is that? There. Okay. And then instance requirement. That's fine. Let's go to the next, because this is coming from the launch template. Okay. And load balancing, it's asking whether we need to attach an existing load balancer. Let's see what the note says. So creates ASG, creates launch template. Okay. So do we actually need to attach a load balancer? So this, yes, because we need it to come from this load balancer, right? So attach an existing load balancer, and then we'll select our load balancer. Okay. Now, let's go to next. I'm still expecting configuration for security group. If not, we'll go back and see. But anyway, so let's start with how the load balancers is supposed to work. So desired capacity, minimum, maximum. So this is where you then determine how high do you want to go, how low, when it comes to scaling in and out. Okay. All right. So now there is scaling policies that we can set. So target tracking scaling policy. So if you select that, you can select the different ways or the functions that determine what your scaling is going to be triggered by. So if you select average CPU, so that means if your CPU goes beyond the target value, let's say you set it to 90, that means when your CPU spikes up to 90, then it's going to trigger a scaling event, which means a new server is going to be spun up. So if we set the minimum capacity 1 and the maximum to, let's say, 10, that means it would always scale up to the maximum of 10. So if you start with 1 and then CPU hits a target of 90, it scales another one. Okay, if you now have 2 servers running, that means 2 Nginx servers in an auto-scaling group, the traffic can be spread across the 2 because it's now load balancing. It's possible that both of them can hit 90. When that happens, then another one scales up again, and then balancing is going to occur across 3. So that's horizontal scaling. Vertical scaling is when you add more CPU and RAM to a single server, but there is a limit to where that can go. And so horizontal scaling like this is the best strategy for high scaling, scalable infrastructure. Okay. So, you can do certain configurations in terms of, seconds, one more before, including in metric. So when is scaling occur, how long, does an instance need to wait before it updates the metric? Because, it's going to be using CloudWatch to gather metrics from your instances. That's how it will know when CPU hits a certain threshold. And then, here it says disable scaling to create only scalar policy. So if you disable this, what this means is when things begin to settle down, then your instances will not be able to scale in. But we don't want that, because when you hit the maximum of 10, what if traffic goes down and your number of users begin to slow down? You don't want to keep 10 servers running because your cloud cost would increase. You want to be able to scale in at that point. Okay. So instant scaling protection optional. So this is to prevent from scaling. Newly launched will protect from scaling by default. So this is, if you enable this, this is the part where it won't. Hold on, it says if protect from scaling is enabled, newly launched instance will be protected from scaling. Right? Okay, so when there's a new instance that is being provisioned, then that instance wouldn't be able to terminate. It won't terminate those instances anymore, because auto scaling will be terminating instances when it doesn't need them anymore. So if you enable this scaling protection, then it won't terminate those instances. Okay, so but the default options are fine, without selecting any of those ones. You just want to be specific about the target you're looking after. In some cases, it might be 70. This decision also depends on the type of infrastructure you're running. So for example, if it's like a data warehouse or something that has a lot of compute requirement, you want to make sure that there is enough gap between when the scale out occurs. Because if you wait till 90, let's say it takes time for the next server to come up, probably because the user data, how it probably takes about 10 minutes for all the scripts to run and all that. You don't want to wait until 90% before scale out occurs. Once it hits 70, you want another one to start scaling, because it's going to take time, and between 70 and 100 you still have time to still keep on using this current server, so I think we're okay with that. So let's click next. So this is if you want to have some notifications in your email, you can use SNS topics, where you can just configure your email, and every time there is a notification of a scaling or scale out, it gets to notify you. So we're going to skip that. So the next one is tags and review. So I'm going to have to go back because I think we've missed something, and okay. So the subnet is where I'm concerned. Okay, yeah, okay, fine, it's been taken care of. So when we were selecting the availability zones, it also picked up the subnet. Okay, that's where I had concerns, but we've actually taken care of it. Okay, so we can actually skip to review. Let's add tags. We didn't do that. Name. So this is MCC ASG Nginx. And this is very important so that anytime autoscaling is creating a new instance, you want to make sure that it uses this tag to tag the new instances. Okay. Next, and then we can create autoscaling group. So updating capacity, and this should then spin up some servers. So let's go to EC2 section. And now you can see that we don't have a server that's getting created by reason of our autoscaling. So we go into the autoscaling and edit the capacity to minimum, let's say 5, for example, and update this configuration. One or more field requires invalid. Okay, that's the, yeah. So this can be lower than the minimum capacity. Then if we refresh this, you'll see that it will start provisioning new instances. So this is running at the moment. We're going to need to access this, but we can't reach this. It has to go through a bastion. As you can see, there's no public interface. There's no way we can reach this directly. So let's refresh. Okay. Okay. So you can see autoscaling has kicked in. It has provisioned more instances and all that. So far, so good. We've implemented everything up to this point, except that we haven't done autoscaling launch template and all that for Bastion. So I guess we can stop here today. So tomorrow we'll get that. So we can at least, first of all, once we start tomorrow, get this, hits our load balancer and see the Nginx space loaded. And then we can finish the infrastructure by provisioning these other infrastructure and then get everything working together. So that's what we'll focus on tomorrow. So the week after will be Terraform, where we'll now automate the whole thing from ground up. So do we have any questions so far based on what we've done today, guys? I know we've been discussing, going along.
No, it's me again, sorry. In Project 15, we created the AMI and the AMIs first before doing the target groups. What do you think? Is that good practice?
Yeah, that's a good practice. So now, first of all, most of the time you're not just going to use AMI that is taken from AWS directly like that. Okay, it's actually a good practice to take a base AMI and then you can update it to whatever standard you want. So you may want to put your own security tweaks into it. Run your yum commands to update the packages or to do whatnot. And then you create an AMI, which becomes your own golden AMI. So that when you're creating your launch templates, you're basically going to be using that. Because the assumption is you don't even trust the AMI that Amazon provides for you. So typically, you would even automate that process using a tool like Packer. So Packer can take a base AMI from AWS, and then you can use maybe Ansible to run some updates on that AMI. It would install things, it would delete things, set some directories, however your application works. Or, you may even want to follow some CIS standards. So if you go to CIS standards for Linux, you can go through some of these compliance hardening tweaks. This is for Ubuntu. So you can read things like this. And then there are a lot of things that are basically recommendations, okay? File system configuration. It tells you what you need to do, what sort of file system patterns to have. And then you can go to configuring update of softwares, file system integrity check. So you configure an Ansible script that basically does all of this, that satisfies CIS standards to harden your image. So the AMI that Amazon provides by default may not have all these standards. So you may want to do all these things on your own. puts Ansible and Packer together to provision this, and then eventually produces an EMI that is approved within your organization. So that EMI ID can then be what you will then put into your launch template. So it's definitely a good practice to do that.
Thanks. Thank you.
Cool. Do we have any more questions? No? Right. So what I would say is tomorrow we'll try to finish this up. During the week, your focus, for those who have started project 16, 17 and all that, that's fine. If you haven't, please try as much as you can to start touching on Terraform, start doing all that, so that the next thing is going to be containerization afterwards, and we can spend a lot more time having fun there. Okay, so
Yes, sir, please, sir.
Thanks a lot for the yes.
Please, sir, before you go, sir, the links you sent before we started, I closed them and they're empty.
They're empty.
Yes, sir.
Okay. So
Mine as well.
okay, yours as well. Okay, so
Same with me as well.
Okay, that's good.
Yeah. Sorry, I was about to ask the same question. How can I get access to the architectural diagram and
okay? So
the
this is
repository?
okay. So this is what we're gonna do, right? You can see this screen when this link. When you go to the browser, do you see this like this? When you go to the browser, do you see this page?
Yes, yeah.
Okay. And then when you go to this and you clone it, you're saying it's empty when you do a clone like this. You don't get to see something like this when you clone it.
Maybe we should clone from when we from the.
Yeah, maybe you can ignore the link I sent, but if you can go to the browser, I've sent the one that will take you to the browser and click on the clone yourself. Okay.
Yeah, I did that as well, and it was empty.
Okay, maybe one person should share his screen and then we can go through it together. So I'm going to stop sharing so that you can share. So someone can just share. John, do you want to do the sharing?
Okay, let me share.
No, that's fine. Olorunfemi has started the sharing, so let's use that. Okay, so go to the browser. And then let's have a look at the repo. Do you want me to share the link again?
Yeah, you can do that.
Okay, let me share the link. Okay, I've shared the link. Okay, so hit on the clone. And then HTTPS, yes. Then go to your terminal. Okay, so what you want to do is run. Is there anything in this folder, this masterclass folder? Is it empty folder?
Is
there are other things?
this empty that's masterclass?
Okay, so you might want to delete that because it might complain that it already exists, because that's what's. Yeah, good. Okay, so now do your git clone. Okay, so click on the, okay, let's let it finish cloning. It's not completed yet. Right, okay. So it might be a case where because you don't have a GitLab account.
I've registered for a GitLab account.
Oh, you've registered. Okay, so it says unable to.
Do I need to connect it from here?
Oh, no. It's trying to go to GitHub. For some reason, it's going to GitHub.
Maybe most people
Maybe
be having the
because
same.
of your global Git configuration.
Okay.
That's what I'm guessing. Let me think.
Hi, Larry.
Yes.
I cloned into my GitHub from GitLab and it didn't give me any issues. What I did was I removed the S in front of the HTTPS.
Oh, really? Okay.
Yeah.
Do you want to try that? That's weird though.
That's what I did. I just did git clone. Although I got some errors, and the errors were in the CI/CD folder, the first one. But aside that, everything is there.
Right. Okay. Okay.
They have a self error.
Yes, they have. Okay. I think this is specific to your laptop. Maybe there is some configuration because it's saying it's timing out on that port and also it's going to GitHub. So I'm guessing you have a global Git configuration that's making it go to only GitHub.
Okay.
Yeah.
Maybe another person can try again.
Yes. Maybe let's have someone else try share their screen. Let's see.
Are you saying, sir, that I must have Git lab account where I can make the work?
Not necessarily. You shouldn't have GitLab account because it's a public repo anyway. It's not like it's a private repository.
Normally, you should just have Git installed on your machine, and then that's it.
Yeah. So if you have Git, that should just work.
I did it, and it's working.
Okay.
I have Git on my account.
Okay. Let's see. Someone else is trying to clone. And it looks like this one is working because I can see 71% already.
Yeah, with mine, it actually cloned the first time. But the thing is, files were missing in the
yeah,
so they didn't copy the main files.
Yeah, so you have to switch into the masterclass -C branch because that's the branch you want to be following along because by next week we'll create new folder. So the only folder you see there should be week 1 and 2.
Mine is still empty.
Yeah.
I removed the S and it's still empty.
Okay, so has anyone been able to clone it?
Yes, I've cloned it.
Yeah, I've tried. I've cloned it. It's 100%.
Okay, so I'm thinking
my
maybe
my own went to 100%, but still empty.
Yes, the same thing with me, 100%, but it's still empty.
Okay, so here one clone proceeded.
And then let me give the error. The error I'm getting is it says pattern unable to check out working tree. That's the error I'm getting.
That's the same error I got also.
Okay, this is weird. Invalid path unable to check out working tree. Okay, see, can you CD into the folder, the DevOps Masterclass folder? CD into it.
Yes, I see it into it and it's empty. I did LS and nothing.
No, you need to CD into it and then do the Git clone.
Yeah, CD into it now. Let's see. Do a CD into that folder first of all. Yeah, use your tab. Okay, yeah, enter. Okay, so run ls command. Let me see.
You want to do myself just some more? Sorry.
Okay, I've muted everyone so you can unmute yourself again. Okay, so ls is empty. Okay, so what you do is do git checkout masterclass -C. Masterclass -C. Okay. Okay, now do ls. Okay, so now it's
Yes.
there.
Yes, it's there. I've seen README and week 1 and week 2. It's there now.
Yes, yes, that's what you
Yeah,
want. So
yeah,
you now
I've seen that myself, sir.
Okay, good. You can now see
So,
into week 1 and 2.
so there's nothing in the main branch. So that's
Yes, which is fine. You don't even care about the main branch anyway, so you should care about this branch. Okay, cool. All right. Thank you very much, guys. It's been an amazing time with you today. So I'll see you tomorrow, and then we'll catch on from there.
All right, thank you, sir.
Thank you very much.
Thank you.
Thank you.
Good night. Thanks.
Yeah,
good
bye.
night.